Hello everyone, and welcome to this Nokia and Intel joint webinar, Delivering High Performance on Nokia's Cloud Packet Core with Intel Xeon. Today, we're diving into Nokia's Cloud Packet Core and how it leverages the power of Intel to deliver exceptional performance and energy efficiency. We'll be exploring how this combination transforms the way we think about networks, letting operators deliver superior user experience while minimizing their environmental footprint. We want to let you know about the key benefits of our collaboration, including unmatched performance, energy efficiency, scalability, and flexibility. Join us now as we delve into the technical details and real-world examples of how Nokia's partnership with Intel is revolutionizing the telecom industry. I'm Brian Davies, Portfolio Marketing Manager at Nokia, and I'll be your host. Today, we're thrilled to have two experts in the field of cloud networking and high-performance computing join us. Gordon Milliken is the head of Packet Core Product Management at Nokia. Gordon brings extensive experience in the design and implementation of cloud-native network solutions and will be sharing insights into the architecture and capabilities of Nokia Cloud Packet Core. Joining Gordon is Chandresh Ruparel, Senior Director, Wireless Core Infrastructure Segment at Intel. Chandresh is a leading expert in the field of high-performance computing and will be discussing the role of Intel Xeon processors in driving the performance and energy efficiency of the Nokia Cloud Packet Core. Together, these experts will give an overview of the impact of this combination on the future of telecom networks. Our chat window is open for live questions, and if we can't answer them during our discussion, we'll send you the answer later. So let's get started. Gordon, we've heard a lot about the increasing demand for high-performance networks. Could you share your insights on what the market expects in terms of network performance and how Nokia Cloud Packet Core is addressing these expectations?
Brian, the expectation from the market is continuously growing. Consumers demand better user experience with faster transmission of data, and service providers expect performance to grow without impacting their cost, be it servers, compute footprint, or technology. At Nokia, we recognize the immense potential of chips to revolutionize core network performance for service providers. We've invested heavily in optimizing our software to take full advantage of all the features available on the latest Intel processors. This optimization has yielded significant results for us. Our optimized software, working jointly with powerful Intel chips, can handle massive amounts of data with incredible efficiency. This means faster download speeds for end users, smoother streaming, and a more responsive network overall, crucial for the demanding applications of 2025 and beyond. This is not just a theoretical advancement, it's reality where we're already seeing it in the field. We've achieved significant milestones in capacity and performance, and we're constantly working with Intel to push the boundaries of what's possible.
Well, let me turn to Chandresh. From Intel's perspective, what do you see as the key market expectations for performance and energy efficiency in the telecom industry? Also, how is Intel addressing these expectations with its latest processor technologies?
Thanks, Brian. So as Gordon mentioned, some of the requirements are fairly obvious, but they're evolving. At an infrastructure level, if you were to translate some of these, a reduction in infrastructure footprint, reducing power consumption and CO2 emissions, automation, a smooth transition to a horizontal cloud-native framework are some of the top asks from the CSPs. Intel has been working with the telecom carriers and partners worldwide for a decade, helping them transition to NFV and now to cloud-native 5G core. These collaborations have allowed us to keep the ear to the ground, understand the requirements of the CSPs, and also their evolving requirements or anticipating them. And if you have the bruises and scars from working with the industry partners through a decade, you realize that in telco industry, it's not just about throwing the technology over the wall and hoping that it's working exactly to address the KPIs that the CSPs are looking for. You have to understand the implementation models, the deployment constraints, the traffic models. You have to understand the platform, the stack, and the applications to be working with partners like Nokia for optimization and delivering stable, resilient, performant, and power efficient solutions. Intel is delivering and making significant strides in silicon technology to begin with. That's table stakes. You have to deliver the technology. For example, Intel Xeon 6 with E-cores is offering multi-fold improvement in rack level density, in reduction of footprint. But this is translated because we are actually working on real workloads. Intel has invested heavily in an internal 5G core stack to develop best practices, silicon features and capabilities, and make sure that it is translating into real TCO and power efficiency benefit when it is deployed at a site level and rack level. And there are multiple nuances in between. The other area that Intel has focused on is power efficiency. And in this, there are several silicon capabilities that we are delivering to the market. But again, they have to translate into easy adoption by the ecosystem and reliable deployment. And so we have developed software and have been working with Nokia very closely to ensure that this translates into significant improvements in power consumption, saving tens of millions of dollars to the CSPs. We have extensively invested in initiatives across telecom industry, making us one of the top contributors in the open source and industry initiatives. And when I say top contributors, it's number one or number two in majority of them for the telco space. We have translated decade of telco core deployment learnings to hardened configs, processes, and support infrastructure, which not only allows for faster deployment of new innovations, but it also helps respond faster to any issues that are faced in the field because we work very closely with the ecosystem and partners. Again, these collaborations have been developed over a decade. And working closely with OEMs, ISVs, and OSVs, while it is crucial with a deep and solid engagement, our collaboration, specifically with Nokia, is about translating silicon software innovations in best practices to a versatile TCO-optimized solution for carriers. Proud to say that we have taken innovations from POC in the lab to deployed solutions in record time. CSPs benefit the most when ecosystem partners work very closely with each other. Pleased to say that Intel's deep and broad collaboration with Nokia is across all the attributes that I mentioned.
So, Gordon, with sustainability becoming increasingly important, what are the market expectations for energy savings in telecom networks? How does Nokia Cloud Packet Core contribute to achieving these goals?
Well, Brian, energy efficiency is a top priority these days, especially with skyrocketing electricity prices and the growing focus on sustainability. CSPs are demanding more energy efficient 5G core software, and they're even factoring in projected CO2 emissions when making their purchasing decisions. Here at Nokia, we've been digging into this issue and collaborating with our technology partner, Intel, and we're seeing some really promising solutions. Here's what we're working on. First, new chip generations like Intel Xeon 6 are inherently more energy efficient, delivering much higher compute capability within a given compute footprint. And within that footprint, better lower power to compute ratios, which multiplies the energy efficiency hardware release on release. Secondly, specifically with Intel, the latest chipsets have advanced power management capabilities that allows tuning of power consumption. Examples are P-state and C-state control.
Hmm.
With P-state control, you can adjust the CPU frequency per core. And with C-state control, you can put unused cores into various stages of sleep. Third, Intel's Data Plane Development Kit, or DPDK, is used to create a feedback control loop with application telemetry feeding Intel's infrastructure power manager, which then dynamically modulates P states and C states to provide only the power needed to drive the applications as network demand changes over the course of the day, the week, et cetera, et cetera. Response times and granularity of steps ensure that applications don't falter when changes are made and there's no compromise whatsoever to CSPs' KPIs. Finally, in addition to dynamic modulation of the power provided to match the actual application power demand, Nokia is leveraging artificial intelligence at the application level to proactively adjust the application compute footprint to match the compute load from the actual consumer load as it changes over the course of the day, week, etc. We've developed a traffic load prediction model, and we're using machine learning results to trigger Kubernetes horizontal pod auto-scaling in order to change that footprint to match the actual user load and therefore minimize power demand. We're confident that these innovative approaches will help us deliver energy-efficient 5G core software, meeting the critical needs of service providers and paving the way for a more sustainable future.
Well, so Chandresh, Intel is well known for its commitment to energy-efficient computing. How are Intel Xeon processors contributing to the energy savings goals of the telecom industry? And what are the market expectations in this area?
So market expectations, Brian, are fairly straightforward. As Gordon mentioned, CSPs are looking to reduce not only operational costs, but reduce energy consumption and CO2 emissions. So sustainability overall is very important. And that means it's not just the Scope 1, but also Scope 2 and Scope 3 emissions that are in play here. And dating as back as 1994, Intel started investing in sustainability when it wasn't even as popular. Using renewable energy for manufacturing process makes products inherently sustainable. On Xeon processors, they're made with 90% renewable electricity. In fact, we maintain our renewable electricity supply at 100% in the US, Europe, Israel, and Malaysia, and achieved 80% renewable electricity globally. At corporate level, we have committed to increasing product energy efficiency 10x by 2030 for Intel client and server microprocessors, and absolutely are on track, in fact, ahead in some cases. We have invested in silicon features, as Gordon mentioned, comprehensive built-in telemetry, highly granular PNC state for frequency controls, and fast frequency changes to be able to address KPI requirements. So KPIs cannot be compromised in real workloads as the power efficiency implementation is deployed. We have invested in software such as Intel Infrastructure Power Manager for 5G Core that takes advantage of these capabilities for easier consumption, easier integration, and has been incorporated by Nokia. And these investments will continue to pay off dividends gen over gen because this is not specific to one technology cycle. It applies to multiple technology cycles as we go forward. We have embarked with Nokia on a collaboration to deliver one of the most power-efficient telco core solution in the market. This collaboration includes Xeon 6 with E-cores and Intel Infrastructure Power Manager software. But there's a lot more to it, as Gordon mentioned.
Well, interesting. Gordon, looking back at 2024, what were some of the key achievements of Nokia Cloud Packet Core in terms of performance and energy efficiency? And also, what are your expectations for 2025 and beyond?
Well, Brian, as I look at 2024 and think about performance, Nokia Cloud Packet Core saw significant improvements in performance driven by advancements in chip technology and software optimization. resulting in increased capacity. We handle more traffic with the same infrastructure, leading to lower cost and better scalability, reduced latency, faster processing time, which is crucial for demanding applications like 5G and edge computing, and improved throughput, leading to higher data transfer rates, enabling smoother streaming and faster downloads. With regards to energy efficiency, Nokia focused on reducing the energy consumption of its cloud packet core solution through optimized hardware, utilizing more energy efficient chips and components, and software enhancements, implementing algorithms and features that reduce power consumption without compromising performance. And in addition, virtualization and cloud native technologies that allowed us to gain flexibility and leverage cloud resources efficiently to minimize energy waste. As I look forward to 2025 and beyond, we're going to continue to focus on performance gains. We're going to push the boundary of performance, aiming for even higher capacities, lower latency, and improved throughput. We're going to do that by continuing to advance to next generation chips, additional newer algorithms and software innovations, and will enhance energy efficiency by continuing to prioritize energy efficiency as a key differentiator, so that we can reduce our carbon footprint, lower operating cost, and most importantly, drive adoption through service providers to use the most energy efficient solutions, so that we'll actually realize this savings in the marketplace.
So, Chandresh, I have kind of the same question for you. What were some of the key achievements of Intel processors in 2024? And what are your expectations for their role in the telecom landscape in 2025?
First of all, great summary by Gordon here. Intel launched Intel Xeon 6 with E-cores, which is optimal for telco-specific workloads, microservices-based workloads in July, which is proving out, working on real workloads, real deployment scenarios for carriers as to be delivering multi-fold increase in capacity and throughput. Nokia already announced adoption of this platform for upcoming release in 2025. And as also we mentioned, I guess, we have a collaboration to deliver the most power-efficient telco core solution in the market. And we are already in CSP trials together with this solution. In addition, our target for 2025 is to rapidly expand Nokia's energy efficient solution to all telco workloads, not just packet core. Another key target looking into 2025 is automation and AI-based innovations that we will be delivering in 2025 as proof points. So there is a comprehensive set of targets to benefit the CSPs and really continue marching forward, delivering to their evolving needs as well as current needs. Power efficiency, TCO, automation, and smooth transitions to the new infrastructure frameworks.
Well, we've covered a lot of ground today. We've explored the market expectations for high performance, energy efficient networks, and how Nokia Cloud Packet Core, powered by Intel Xeon processors, is delivering on those expectations. Now I'd like to invite both Gordon and Chandresh to share their final thoughts on the future of cloud networking and the role of this innovative solution in shaping the telecom landscape. Gordon, what are your final thoughts?
Well, Nokia's optimized software, working in tandem with our compute technology partner Intel, delivers unprecedented performance levels while simultaneously reducing costs by minimizing infrastructure needs and offering flexible deployment options across various network layers. Furthermore, Nokia's leading the way in energy-efficient 5G core software through innovative approaches like use of Intel's DPDK telemetry, feedback loop, infrastructure power manager, and Nokia's AI-powered traffic prediction, ensuring a sustainable future for CSPs and their customers.
So, Chandresh, how would you summarize Intel's position on this combination?
We are really excited with what we have achieved and what's ahead. In our collaboration with Nokia, we have a compelling set of platform and software capabilities, technical skills, and very important, a strong teamwork. We are really excited because with Nokia on this next generation mission, we are looking to continue delivering compelling TCO, power efficiency, automation, a smooth transition for CSPs to a horizontal cloud-native framework, and breakthrough AI-based innovations for the core infrastructure. The possibilities are immense.
Well, thank you, Gordon and Chandresh, both for your insightful perspectives and valuable comments in this webinar. Today, we learned a great deal about the exciting future of cloud networking and the crucial role that Nokia Cloud Packet Core and Intel Xeon processors play in shaping the telecom landscape. We hope this webinar has provided you with valuable insights and a deeper understanding of the technology driving the next generation of telecom networks. We encourage you to continue exploring the possibilities of cloud networking and to stay tuned for future developments in this dynamic field. Thank you all for joining us today. This concludes our webinar.